All right, welcome back for part 2. So we're looking at this guy here with the 4 steps we kind of want to go through each time. So we've talked about you want to find the period, okay, to figure out how long you need to take to get all those points. So is it going to take you 2 pi? Is it going to take you 1 pi, half a pi, 4 pi, whatever? Okay, so that's going to be a horizontal shift. Okay, maybe one time it takes this long. Maybe the next time it takes this long to get all the way through it. That's what the B value is going to do. We've talked about the amplitude down here, min minus max divided by 2. Okay, just remember it's your A value, and it's going to be the height of each individual wave, not both of them together. B value, make sure this guy's all factored out to help us get the period. The C value, okay, that's going to be just like something you did in Algebra 2. Like this. Okay, clearly it's a quadratic because of the x squared. This guy's going to make it go right 5 because it's negative. This guy's going to make it go up 6. Okay, and this guy, the 2, is going to make this guy skinnier. It's the same idea. So when we see a minus c, okay, it's always opposite. So it's going to go positive. If we see a plus c, it's going to go negative. But I got some equations that'll help us and not have to worry about that too much. All right, and lastly, your vertical shift out here, the D value, like we talked about, it moves this graph up and down. Okay, so minimum or maximum plus the minimum, and then divide that guy by 2. Okay, and figure out how much we're going to shift this guy up and down. Okay. Like I said, we're basically doing the same thing with the same shifts we used to do with quadratics or square roots or anything you guys did in your previous classes, but now we're going to have a period of 2 pi, okay? These 2 equations you see here will work every single time, okay? It may take longer than visualizing it, but you're guaranteed to get this guy right. I do them this way, so if you look at any of my answer keys, you'll see me literally transform these 5 points down here. Now, it's easy for me if you guys do this way because I can see your math with it, and instead of going, oh, well, this guy's going to be upside down, it's going to be right pi over 2, it's going to be moved up 4, that's a lot to keep track of, especially when that period starts changing, okay? So I just do everything this way. Find what works for you best, but I encourage you to do it this way. Okay, here's how we do it. Let's say we're doing a cosine. So these guys right here are all our cosine values, okay? You have those on the very first thing we did. We have cosine values here, and you guys also should take time and put them on this little cheat sheet, okay? So we take all our original cosine values, and we start moving them. Okay, each point's going to have an x-coordinate and a y-coordinate, obviously. You know, here's your x, here's your y, all the way down. If you want to find the new x-coordinate, take your old x-coordinate and divide it by b, okay? Because the only thing that's going to move things in the x direction are the period and the c, okay? So c, again, is a left-right shift. B tells us how long horizontally it takes to get through. Okay, does the whole graph happen in this, or does the whole graph happen in this? Okay, those are things that change x-coordinates. Okay, to find your new y-coordinate, you take A, because that's going to make it taller or shorter, and multiply it by the old y, and you're going to plus or minus D. So if D is positive, we're going to shift it up. If D is negative, we're going to shift it down and subtract. This guy's really nice here, okay, because we're just always going to subtract whatever the C value is. Okay, so if it is a negative, so if you had something like sine of x minus pi over 2. Okay, clearly this is a negative, so it's going to send it right pi over 2 units. So if we use this formula and we say, in this case, c is negative pi over 2, if you do minus minus, that's a plus, that sends it in the right direction. Okay, so keep those 2 formulas in mind. Okay, write them down, box them up. Okay, let's look at how we actually graph some of these. Okay, so first one here, we got a sine of x minus pi over 4. Okay, so it's not just your standard sine graph, but we're going to be transforming it. Okay, so you look at it. Okay, A is going to be a 1, B is going to be a 1, C is going to be a negative pi over 4, and D is going to be a 0. So all this guy is a normal sine graph, but everything's going to be shifted right pi over 4. Okay, so we would have our typical sine graph that looks like this. Okay, clearly here's 2 pi. Every one of these 5 major points is just going to go right pi over 4. And we'll start practicing some of this stuff tomorrow. Okay, so we're going to use the formulas. We're going to shift this guy right pi over 4. This guy isn't bad if you wanted to start with the original and then just literally shift everything over. But when you get a lot of transformations in there, it becomes more difficult. Okay, so don't worry about graphing it. We'll start practicing it tomorrow. Let's look at the second one. Okay, A is in negative 1. Now, if I gave you x squared and I gave you negative x squared, only difference between them, x squared opens up, negative x squared opens down. So this sine graph is going to be upside down. So instead of it looking like this red one here, this point would actually end up down here. This point would end up here. And this guy would go down first and then up instead of up and then down. Okay. B is a 1, so we're not changing the period at all. That's always nice. C is a 0, no left-right shift. And D is a 2. So we would take everything after we flip it upside down, we'd scoot it up 2. Okay, so literally every point's going to move up 2 units in the y. Okay, last one here. Cosine of a 3x. A is a 1, so it's still going to have the same amplitude. Now, the B is a 3, and we'll come back to that in just a second. Okay. C is a 0, so we're not going anywhere left and right. And D is a 0, so we're going nowhere up and down either. Now, what this B does is we said anytime you have one that's not a 1, you got to say period is 2 pi over B or 2 pi over 3. Now, this is really going to change some things. So instead, a cosine graph, okay, it's like the little bowl thing. All 5 points used to happen in 2 pi. All 5 points now are happening in 2 pi over 3. So that's where the trig graphing paper really comes in handy. So, you know, approximately here's a pi. And again, we'll do nice and neat graphs tomorrow. Okay, here's 2/3 of a pi. Everything's going to happen from there to there now. So this guy really got shrunk up horizontally. Okay. Don't worry about that because we're coming back to that's what we're going to be doing in class. If you wanted a head start, you can look at it. So think about some questions. Think about your transformations you guys have done in college algebra. Look at these basic shapes that you have here. Okay, think about the 5 points. Understand how we get these guys all set and ready to transform. And we'll start using these formulas first thing tomorrow. Okay, come with questions you guys have.